Dear children, let us study new chapter today, carbon and its compounds. Life on earth not only depends on air and water but also on certain biomolecules such as carbohydrates, fats, proteins, etc. In fact, carbon is the third most important element after oxygen and hydrogen. Carbon has many uses. The food we eat, the clothes we wear, medicines we use contain carbon. Some compounds of daily use like soaps, detergents, perfumes, plastic, paper, etc. are carbon compounds. In the form of diamonds, carbon is used as a gemstone. Carbon is a nonmetal. It has valency of 4. It cannot form ions under normal conditions. This is so because for a carbon atom, it is neither easy to gain nor lose for electrons in its out valence shell. Thus, carbon forms compounds by sharing its valence electrons with other carbon atoms or with atoms of other elements. Symbol of carbon is C, atomic number is 6, electronic configuration is 2, 4, valency is 4. Let us see the occurrence of carbon. The name carbon has been derived from Latin word carbo. Carbo meaning coal. Carbon is the major constituent of coal, petroleum, and other fuels. Carbon is a Carbon is found in nature in both free and combined states. In free state, carbon exists in coal, diamond, and graphite. Coal is a decomposition product of plants. It is formed from dead remains of plants under the earth due to high temperature and pressure. The process of conversion of carbon compounds of the plants into carbon or coal is known as carbonization. Diamond and graphite are the crystalline forms of carbon found in nature. In combined state, carbon occurs as oxides, minerals, hydrocarbon, and complex compounds. Let us see what are the different forms of carbon in combined state. Carbon combined with oxygen forms carbon dioxide and carbon monoxide. Air contains about 0.03 percentage carbon dioxide and the carbon monoxide occurs in volcanic gases. Next, carbon forms complex compounds in plants and animals. For example, carbohydrate, protein, fat, vitamins, etc., obtained from plants are compounds of carbon. It occurs as minerals. All carbonate minerals contain carbon. For example, limestone CaCO3, magnesite MgCO3, dolomite MgCO3 dot CaCO3. Dolomite is the mixture of magnesium carbonate and calcium carbonate. Next, carbon present in all hydrocarbons. Hydrocarbons are the compound of carbon and hydrogen. For example, natural gas, methane, CH4, and petroleum is a mixture of various hydrocarbons containing a large number of carbon atoms. Let us study the compounds of carbon. The compounds of carbon are divided into two categories: organic compounds and inorganic compounds. All carbon containing compounds except carbon monoxide, carbon dioxide, carbonates, and bicarbonates are called organic compounds. In other words, organic compounds are compounds containing carbon and hydrogen as main constituents and found in living organisms or derived from living organisms. For example, KHCO3, potassium bicarbonate. It contains carbon and hydrogen, but it is not formed in living beings. Then it is not an organic compound. Some organic compounds are vinegar, formic acid, carbohydrate, fat, proteins, etc. Next, inorganic compounds. All non-carbon compounds along with carbon monoxide, carbon dioxide, carbonates and hydrogen carbonates are called inorganic compounds. Or we can learn inorganic compounds are compounds that do not contain carbon and hydrogen simultaneously and found in Earth's crust or atmosphere and are prepared from minerals or non-living things. In inorganic compounds, one of carbon and hydrogen may be present. If both of carbon and hydrogen are present, but the compound is not derived from living beings, then it is inorganic. Example, sodium bicarbonate, NaHCO3. Here are some examples of inorganic and organic compounds. Read and learn the name of the compounds. Next topic about crystalline and amorphous solids. Solids are classified into two classes: crystalline solids and amorphous solids. Solids have well defined or definite structure or definite geometrical form called crystalline solid. Example, common salt, sugar, and diamonds. Amorphous solids. Solids do not have definite structure or definite geometrical form called amorphous solids. Example, glass, wax, plastic, etc. Let us see the characteristics of crystalline and amorphous solids. In crystalline solids, the particles like atoms, ions, and molecules arranged in definite pattern and in three-dimensional order. Amorphous solids, particles do not have regular arrangement and if a crystalline solid is cut with a sharp object, it would always give parts with smooth edges, whereas an amorphous solid cut into surfaces with rough and uneven edges. Here are some questions for you. Learn and write its answers in copy and also do the related questions from the exercise. Thank you.